Hello guys, and welcome to another episode of A Journey into Physics. In today's episode we're going to discuss about moment of inertia. The moment of inertia is also known as angular mass or rotational inertia, and it is a tensor that describes the needed torque in order to achieve a desired angular acceleration about a rotational axis. In order for you to understand the moment of inertia better, you should realize that the moment of inertia has the same role as mass in the linear movement. In the linear movement, we know that mass is a tensor that describes the force that is needed for an object to achieve a certain acceleration. The same role has the moment of inertia for angular acceleration in a rotational movement. First of all, we're going to discuss about the moment of inertia in point mass systems. As we can see on the whiteboard, we have the rotational axis. The point mass is m1 and m2 that rotate around the axis with radius r1 and r2 accordingly. So, as we can see on the whiteboard, in each separate mass, the moment of inertia is the product of the mass and its radius from the axis squared. And for the system, we can see on the whiteboard that the moment of inertia is the sum of the products of masses and its radius from the rotational axis. Let's move on to the moment of inertia in physical objects. Just like we did before in the episode of center of mass, also here we're going to assume that the object constitutes of several point masses. So, again, because it is a system of point masses, we have the rotational axis, and the moment of inertia is also again the sum of the products of each point masses and its radius from the rotational axis. But since it's a continuous sum, we use the integral. So here is the mathematical expression and equation about the moment of inertia in physical objects. So, in order for you to understand better what we have talked before, we're going to find out the moment of inertia of a uniform rod about an axis on its center of mass. We have already found in the center of mass episode that in a uniform rod, the center of mass is around its middle. Let's see what we have here on the whiteboard. First of all, we can see our thin uniform rod. In its center, the rotational axis, and we can see a mass that we have taken from the uniform rod that is away from the rotational axis by a distance x. First of all, we're using the definition of moment of inertia in physical objects that we have already talked before, and we have the equation number 1. Now we're using the mass density in general in order to find out the mass equation about the mass we have taken from the uniform rod. We also use the uniformity rule that since a rod is uniform, an object in general is uniform, its density does not change at all. No matter where on the uniform you measure, the density is the same. So the mass density of the uniform in general is its mass divided by its length. And then we have the final equation about the mass that we have already taken, and we call it number 2. Now we have the first equation and the second equation. We put them together and it gives us this mathematical formula. We move out of the integral the m divided by L quantity because it's constant. We solve the integral and we find that the moment of inertia of the uniform rod in an axis that's about its center it's the following. I really hope that you liked this video. If you did, please subscribe to our channel, comment and share this video. You can also follow us on Facebook, Twitter and Google+. You can also follow us in the annotations that are here on the whiteboard, or if you're mobile, links are below in the description. Thank you again and see you in another episode of A Journey into Physics.